In this video, we will discuss how to determine whether or not a molecule is polar. I will explain what it means to be a polar molecule, show how to draw dipole moments, and determine the overall polarity of molecules using several examples. Polar molecules have one end that is slightly positive and another end that is slightly negative. In this water molecule, the oxygen atom will have a partial negative charge, and the hydrogen atoms will have partial positive charges. To find the polarity of a molecule, we need to know electronegativity values. Electronegativity is how much an atom attracts electrons when part of a molecule. Fluorine has the highest electronegativity value at 4.0, meaning it attracts electrons the best. Hydrogen, on the other hand, only has an electronegativity of 2.1, meaning it does not attract electrons nearly as well as fluorine does. Hydrogen and fluorine come together to make the compound hydrofluoric acid, which has one hydrogen and one fluorine atom connected by a single bond. Since fluorine has a much higher electronegativity than hydrogen, the electrons are pulled closer towards the fluorine, giving the fluorine a partial negative charge, and the hydrogen a partial positive charge. This symbol is a lowercase Greek delta, and it means partial, in contrast to the full charge in an ion. Here's the Lewis structure for the water molecule. Since oxygen has an electronegativity of 3.5, it will pull electrons closer to itself than the hydrogen, which only has an electronegativity of 2.1. We'll draw the dipole moment towards the oxygen atom to show the movement of electrons. Overall, electrons are pulled up towards the oxygen atom. So we'll show a partial negative charge on the oxygen and partial positive charges on the hydrogen atoms. Water is a polar molecule because it has this negative end and positive end. Carbon monoxide is also a polar molecule, as oxygen pulls electrons towards itself, leaving the oxygen partially negative and the carbon partially positive. Carbon dioxide, on the other hand, is nonpolar, even though it has the same two elements, carbon and oxygen. Oxygen's electronegativity is 3.5, and carbon's electronegativity is 2.5. So that's why we draw dipole moments towards the oxygen. However, because of the symmetry of the carbon dioxide molecule, the dipole moments cancel each other out. That means that overall, there is no net movement of the electrons, and the molecule is nonpolar, even though it has polar bonds. In the methane molecule, there's a very small difference in electronegativity between carbon and hydrogen. When we draw the four small dipole moments towards the carbon atom, we see that the molecule is symmetrical due to its tetrahedral shape. This means that the electrons are evenly distributed on the molecule, making it nonpolar. Carbon tetrachloride also has a tetrahedral shape and is symmetrical. The molecule has four polar bonds, and the electrons are pulled more towards the chlorine. However, the symmetry of the molecule means there's no overall polarity. The molecule has polar bonds, but it is a nonpolar molecule. Ammonia, NH3, has bonds that are even more polar. Nitrogen has an electronegativity of 3.0, and hydrogen has an electronegativity of 2.1, meaning the difference is 0.9. We would draw dipole moments towards the nitrogen. Because NH3 is a trigonal pyramidal shape, the polarity does not cancel out. The nitrogen will have a partial negative charge, and the hydrogens will have partial positive charges. This molecule is polar because it clearly has a negative end and a positive end, as the electrons are pulled upwards towards the nitrogen. This is an example of a molecule that has polar bonds and is polar because of its asymmetry. Sulfur trioxide, on the other hand, has a trigonal planar shape because there is no lone pair of electrons on the central atom. When we draw the dipole moments, they're symmetrical. This means the molecule will be nonpolar overall because there's no net dipole moment. The electrons are pulled equally in opposite directions, and the dipole moments cancel out. The molecule has polar bonds, but it is nonpolar overall. To summarize, asymmetrical shapes will make molecules polar. Bent and trigonal pyramidal molecules will always be polar because of their asymmetry. The other molecular shapes will be nonpolar as long as it's the same elements around the central atom. For example, if you have a carbon attached to two oxygens, the molecule is symmetrical and will be nonpolar because of this symmetry. This was true of sulfur trioxide too. However, if you have a fluorine at one end of a tetrahedral and hydrogen atoms at the other ends, the molecule is no longer symmetrical. There will be a net dipole towards the fluorine atom because it's pulling electrons more strongly towards itself, and the molecule will be polar. Even though this molecule has a tetrahedral shape, it's not symmetrical because it has one fluorine and three hydrogens around the central atom. When a molecule does not have symmetry, it will be polar.